And we've been told that 2z minus 3 is a factor of this big long thing here. So look, I'll do a grid divide this time rather than doing it in my head so you can see a bit of everything. So I'm saying 2z times by what gives this? It's z squared, isn't it? So that gives me 2z cubed, which is what I wanted. But as a byproduct, it gives me minus 3z squared. Now I don't want minus 3z squareds, I want minus 5 of them. So I need another minus 2z squareds. How do I get that? Well, that's 2z times by minus z. But as a byproduct, we get minus z times minus 3, which is 3z's. We don't want 3z's, we want 7 of them. So there's an extra 4z's to have. And how do we get that? Well, it's that times 2. And luckily, 2 times minus 3 makes minus 6, which is what we wanted. So factorising this thing now, we can see I've got 2z minus 3 and z squared minus z plus 2. Can we go any further? Does that factorise any more? I doubt it. Just having a think. So for part B, when does this equal 0? So you've got one answer here, of course, when z is 3 over 2. And the answer is when this bit here is, I'm so tempted to throw it in the calculator, but it does say show you're working clearly. So I suppose I'm going to have to sort of use the formula here. So I go minus b plus or minus the square root of b squared, which is 1 minus 4 times a times c all over 2a. So I've got, that makes minus 7, doesn't it? And so I've got a half plus or minus 7 over root 7 over 2i. Again, I'd whack that into the calculator to check I got the right answers. Yeah.